We're going to talk about arithmetic and geometric sequences formulae. Firstly, arithmetic sequences formulae. So there are three formulae we use here. One is the common difference, which is simply the nth term minus the n minus 1th term. So you take any term in the sequence, subtract the previous term to get the common difference. The next formula is to find the nth term. For that, you need to know the first term and the common difference. And the formula is simply the first term plus n minus 1 times the common difference. And the last formula is the sum of the series. This is given by Sn equals n by 2 times 2 times first term plus n minus 1 times common difference. Let's look at an example that illustrates the arithmetic sequences formulae. So consider the arithmetic sequence 1, 5, 9, 13, 17. If you look at the sequence, then you're asked to find the common difference, the next term, the 100th term, and the sum of the first 5 terms. So let's find the common difference first. Use the formula, the nth term minus the n minus 1th term. Choosing the second and the first terms, you get the common difference as 5 minus 1, which is 4. You could alternatively do the third term minus the second term, 9 minus 5 equals 4, and so on. Then let's consider the next term. As you can see, there are 5 terms in the sequence. The next term will be the 6th term. And so that can be called U6. If the expression is given as un equals u1 plus n minus 1d, then u6 is the same expression with n substituted as 6. Put the values of u1 and d in, and the answer is 21. Thirdly, let's try to find the 100th term. The 100th term is denoted by u100. So if un is u1 plus n minus 1d, then u100 is 1 plus 100 minus 1 times 4, substituting the values of u1, n, and d. Computing this, it's 397. Finally, let's find the sum of the first 5 terms. The first 5 terms as a sum is given by S5. The general formula is Sn equals n by 2 times the first term plus n minus 1 times d. Substitute the values of n, u1, and d, and that gives us an answer of 46. Now let's go to the geometric sequences formulae. There are again 3 different formulae. The first one is called the common ratio, which is the nth term divided by the n minus 1th term. Simply take any term in the geometric sequence and divide that by the previous term to get the common ratio. The nth term is given as un equals first term times common ratio to the power n minus 1. And finally, the sum of the series is given as Sn equals u1 times 1 minus r to the power n divided by 1 minus r. Consider the example of the geometric sequence 2, 4, 8, 16, 32. Find the common ratio. Use the expression to do that. You also have to find the next term, the 100th term, and the sum of the first 5 terms. So the common ratio is given by the nth term divided by the n minus 1th term. Take any term, let's say 8, divide that by the previous term, 4. It's also the same as 16 divided by 8 or 32 divided by 16, etc. And the answer to that is 2. Then let's find the next term, which is the 7th term. So apparently there is one more term shown here, 64. So there are 6 terms in this sequence. The 7th term can be called U7. and that is given as un is equal to u1 into r power n minus 1, or u7 equals 2 into 2 to the power 7 minus 1, which gives us 128. And finally, or before that, the 100th term is given by un equals u1 into r power n minus 1. So u100 is 2 into 2 to the power 100 minus 1. Put the values in and you get 1.2676506 times 10 to the power 30. Finally, the sum of the first 5 terms. The sum of the first 5 terms is given by this expression that we saw earlier. If you plug in all the values, you get 62. If you verify this by adding up the first 5 terms, you also get 62.